Good evening, everybody, and welcome to BCS Edinburgh Branch webinar, Robots as a Third Generation of Personal Device. My name is Mike Hurst from BCS Edinburgh Branch, and I'll be handling the technical side of this meeting. Before we start, a quick note on GoToWebinar for people who are not familiar with it. Depending on whether you are running the desktop app or in browser, you'll see something like the panel on the left or the browser page on the right. By default, you are muted. You can click the mic icon, labeled A above, to unmute yourself, though we need to allow that first. The hand icon, labeled B, will notify us that you are requiring attention. You can ask questions by typing into the question panel. If you are having technical issues during the session, then please use the question panel and I'll try to help. To allow smooth running of the session, we'll take questions at the end of the presentation. Either typed questions via the question panel or raise your hand and we'll unmute you to ask your question. We are recording this talk and it will be available on our BCS Edinburgh Branch site and on the BCS YouTube channel. So I'll now switch presenter back to Daniel, and while we're doing that, I'll hand over to Seb to introduce our speaker for this evening.
Thanks, Mike. I'm very happy that Daniel has found time to come and speak at the BCS. He's currently quarantining in Barbados on his way to the United States to take part in the semi-finals of the Anna Avatar X Prize. So this is a competition that's to do with Telepresence, and if you don't know what Telepresence is at the moment, you surely will do by the end of the session. I have met Daniel before. I know one of his colleagues in Cyberselfs a lot better, a guy called Professor Prescott, who came and gave the Sidney Mickelson lecture for the BCS at the Edinburgh International Science Festival a number of years ago. So this is a continuation of the Edinburgh BCS's relationship with Cyberselfs, Telepresence and robots. And so I think without any further ado, I will hand over to you, Daniel. Very much looking forward to your session.
Thank you so much, Seb, for that introduction. Can I just check that my screen is visible?
It is.
Perfect. So I'll launch straight into it. So the talk for today is called Robots, the third generation of personal devices. But before we start talking about robots, it's always useful to get a bit of context from the other generations of personal devices. And personally, I've always found it really amusing that to look back on predictions made in the early days of what is today life-changing technologies, like the PC or the laptop or the mobile phone. And it always impresses me as to how wrong some of those predictions actually turn out to be. And so we've got, when it comes to personal computers, the chairman of IBM in 1943 saying that he thinks there's only a world market for maybe 5 computers. Similarly, the president of digital equipment in 1977 saying there's no reason anyone would want a computer in their home. And similarly, again, for laptops, we've got the New York Times in 1985 saying things like the computer industry has assumed that everyone wants a keyboard and as an extension of their fingers when talking about carrying laptops around, and how bizarre they found that at the time, and also how they predicted that laptop computers would remain a specialized niche market no matter how inexpensive they become. And the same you'll find for the second generation of personal devices, mobile phones and smartphones. You've got McKinsey and Company back in 1980 trying to predict the next 20 years for AT&T, and they came up with a figure that by the year 2000 there'll be less than 1 million users in the US for mobile phones. And similarly for the iPhone and for smartphones, a lot of people predicted, oh, no one wants to check their emails all the time, they don't want to be reachable all the time, and that also includes a prediction from the CEO of Microsoft back in 2007, saying that there's no chance that the iPhone is going to get any significant market share. And this all continues to happen even today, and nothing's really changed. Even today, we talk about the future of robotics in very similar ways. Robots are too expensive. Robots don't have software that can meet my needs. Who would want a robot in their house anyway? But there's also an added dimension to the arguments against the future of robotics, and that is jobs. Unlike previous generations of personal devices, robotics are seen as a threat to the livelihood of many. And if you search for robots and jobs in Google, you'll find this figure from Oxford quoted over and over. Robots will displace 20 million jobs by 2030. And a headline like that really grabs your attention. And the conclusion in most minds is, well, robots will be taking away our jobs. But that's not the full story. Each generation of personal device has seen the birth of a new and far-reaching global industry that is key to our way of life today. And with robotics, that is no different. So the problem that the robotics industry faces today is actually, how do we effectively train those 20 million displaced employees so that we can supplement the workforce that's required and that's being forecast is needed by the robotics industry? And one only needs to look at the car automation industry to see this in action today. Between 2010 and 2015, in the US, the number of robots grew by 60,000, while employment increased by 230,000. So those are 230,000 new employees for the 60,000 new robots that were employed to replace and take care of specific tasks on the work line. And you see that also as well with Germany, where you've got an addition of 14,000 robots, but an addition, in retrospect, of 93,000 employees. And this is the reality, because for every job replaced by a robot, you have jobs being created to maintain that robot, to service it, create software for it, and updates, as well as designing better versions with more features. So the question we actually need to ask ourselves today when it comes to robotics is twofold. First of all, how do we incentivize the students of today and of the future to learn robotics? And second, how can we facilitate the growth of the robotics industry in order to sustain the re-employment of all the displaced workers? And these are the questions at the foundation of what we do at Cyberselfs. We spun out from the University of Sheffield on March 2020, and our vision is to realize the full potential of robotics. However, to understand the solution for tomorrow, we first need to understand the robotics industry today and the roadblocks that it is currently encountering. So first of all, robot users. Users currently lack the applications that they need. And this has been, I've experienced personally, going out to different tech events where I'm constantly being told, we bought this robot for our business, we wanted to do this application, but we didn't find anything. And so now the robot's just collecting dust in the corner. And the root of that cause is because one of the big things with robotics today is that different robots have to be programmed very differently. Each robot usually comes with its own niche of software tools and libraries which are needed to be able to control the robot and access the information coming from the robot. And this presents a significant roadblock. Talking from personal experience, in my work at the University of Sheffield, as a researcher before starting the company, I had started my career working with one specific robot, which it took me half a year to learn how to control that robot. But then as the research progressed, we needed to apply those principles, apply the applications that we created to a different robot. But in order to do that, we realized that we'd need to re-engineer a significant part of the code that we'd created for the application, which makes it unfeasible. And this is one of the key issues today. It's unfeasible, it's not financially viable for a developer who's interested in robotics to spend months, even years, creating a robotics application that can then only be sold to a very small niche of robots, population sizes of up to 10,000. So the revenue that you can generate isn't enough to warrant the effort that you're putting in. And finally, this leads again to robot manufacturers, where the creation of the robot takes so much time and effort and cost, because they're not only focusing on how do we make the best hardware that we can, but also all the other layers that they need to build on top of the hardware, such as the software, the applications that they need to create themselves in order to sell the robot. And so it becomes a vicious circle, one leading to the other, where progressively it's more and more difficult to enter the market and create a viable business without significant investment, which is only achievable for a small number of businesses. And so this is something that we wanted to change at Cyberselfs. And we came upon these roadblocks purely through our experience as to what's happening in the robotics world as well. You might have heard recently of SoftBank pausing the production of their Pepper robots because they weren't selling enough. And in the case of SoftBank, they didn't actually go bankrupt, but the same has happened to a couple of other companies who have actually gone bankrupt after creating really good piece of hardware, but which couldn't deliver on the software side. And so our solution is AIMOS, a universal programming language for robotics. And what makes AIMOS unique is that it allows developers to easily create software that is independent and completely agnostic of the robot that it is actually controlling. And this in turn empowers them to sell their applications to users who now have a means of finding easy to use and off-the-shelf software that works on any robot of their choosing. And this in turn incentivizes robot manufacturers to focus more on the hardware, because once they've got the hardware solution and then integrating with AIMOS, they now have access to a base of users who have bought AIMOS-enabled applications, and also all the apps created by robot developers, which are immediately applicable to their hardware platform. And so what makes us unique in comparison with other robot programming languages? And that mostly boils down to the accessibility of AIMOS. Our solution runs on multiple different programming languages. And even better, it runs on all major platforms. So you can create robot applications that run on any desktop, that can run even on mobile devices or directly in the browser. And by doing so, you create applications that already have established means of providing those applications to users, and at the same time are able to function with multiple robots. And even better, we have created the AIMOS library in such a way that is up to 4 times faster to control robots over the internet. So it is typically between 3 to 4 times faster than a regular video call to actually connect with and remotely control robots using AIMOS. And here is the range of robots that we've already integrated within AIMOS. We've got around 10 robots so far, with other robots in the pipeline. And the key thing to notice here is that these aren't all robots with the same body shape, with the same body morphology. Some are humanoid with hands and arms. Some are simply tablets on wheels. And there are others which are ground platforms or don't have arms at all, or even underwater. This is part of what drives us at Cyberselfs, is making our code completely agnostic of the platform that it's running on. So it can separate the complexities of the hardware from the complexities of the application. And so the capabilities of AIMOS are that it's internet enabled. You can instantly connect with robots remotely and with low latency. It drastically simplifies development compared to other software libraries, which have a steep learning curve. Lightweight and portable, all this fits within 30 megabytes. And finally, the apps are instantly available to run on the robot and providing the functionality that users are looking for. But how do we make AIMOS robot agnostic? And here lies the key for us. Our guiding principle is to use AIMOS and to think about AIMOS as a robot nervous system, a universal layer that lies between the brains and the bodies, and which translates between the two. Much like you'll find in biology, you've got a lot of different shapes and body shapes for animals, but the underlying hardware for the brain is all the same. And that was the starting point for us with AIMOS. And so the solution is to group the inputs and outputs of a robot into sensory modalities. And the sensory modality is a group of perceptions, stimuli, and actions with a named category. And we'll give an example of sensory modalities in a few. The key thing about sensory modalities is that they group perceptions, but they're also directional. So you've got modalities which are outputs. If you're thinking about the human body, which we generally like to resort to, an output is me waving my hands, me moving around, or me speaking. That's an output from my body going into the environment, or an input, which is an input from the environment coming into the body or the brain, such as feeling of touch, vision, hearing. And those directions are relative to a brain. So here's an example of how we map the different inputs and outputs of a robot to a human mapping, which serves as our benchmark, as our universal representation for all of these robots. So we've got cameras form the vision, microphones form the ears, speakers, which are for the speech and voice. The difference here being speech is text being converted into speech versus voice being audio output. And then finally, the motors, which form the motor modality. And to give another example, here's an example with an underwater robot. Same, it's got cameras, which are the vision modality. It's got microphones to hear. It doesn't have any speakers, and so those can be dynamically, any output to speakers can be dynamically avoided during runtime, and that's all taken care of by AIMOS. And finally, you've got the motors, again, feeding into the motor modality, feeding into a human representation for all the motor inputs and outputs. And so the anatomy of an AIMOS application follows a very simple pattern where you start with the user logging in. They retrieve a list of robots that are available to them and are active. And those robots can be anywhere around the world. They finally connect to one or more of those available robots. And they open the channel of information to or from the robot by issuing an open modality. And that opens the modality for the sensory modality that you are requesting. So for example, vision, audition, motor. And then finally, the app logic is very easy. Using the robotics loop of sensing, deciding, and then acting, you can get modality and the modality name. So get modality vision gives you all the vision information regardless of the robot. You can then operate on that information. And finally, upon making and reaching a decision, you set the modality to set an action to be performed by the robot. And after all that's done, you can disconnect from the robot and finally close everything up. And that's the whole anatomy of a robotics application. It doesn't need to be more complicated than this. And our first application is Teleport. It is a telepresence application that we've built using AIMOS. And it's our first AIMOS application. It's there as a test bed. It's our hello world. And this is a one-to-one mapping between the robot and the human, which is operating the robot remotely with the aid of a VR headset, like the Oculus Quest. Or as you can see, one of my colleagues there in this BBC video, who's using an Oculus Quest as well to control a Pepper robot. That is, of course, within the room, but we have done and tested this at a distance, our record being over 7,000 kilometers from Qatar to Sheffield, controlling a robot in real time without causing VR sickness to the user. And this is the application that we're taking into the Anna Avatar X Prize competition. And speaking about the Anna Avatar, we're semi-finalists and we'll be progressing in September, in a week's time. Very exciting times for Cyberselfs. But the applications, the use cases of this are very, very interesting. So, for example, remote tourism. If you think about trying to be more green, trying to reduce the emissions from travel, such as flights or car transportation, Telepresence is a solution to that. It's a way of reducing the emissions while also being able to experience the remote location as if you're there. And these are a couple of applications that we're looking to deploy within the next year in Malta, where you can either control a humanoid robot overlooking the Grand Harbor, or even make use of an underwater ROV to remotely explore one of the many wrecks that are present in the Mediterranean Sea around Malta. And so we've got multiple collaborators here on all three areas of our interest, and they help us cater our solutions. They help us to hone what we actually need to be doing in order to progress and make the creation of robotics applications more efficient. And finally, a word around what we provide. So we provide drivers to integrate robots to make them internet accessible, and we provide those to the robot users. We provide manufacturers with a way of quickly integrating their hardware with our software platform. And finally, we also provide a free SDK for robot developers and a simulator that's coming up for developers to start creating their applications without any hindrances. And none of this would be possible without the founders at Cyberselfs. Got Dr. Michael Sussy, who is our operations officer and communications lead. I've got Richard Waterstone, who is the managing director and sales lead. And as Seb mentioned previously, we've got Tony Prescott, who's our chief scientific officer. We are Cyberselfs, and we are here to realize the true potential of robotics. Thank you for joining in, and please ask me anything you'd like.
Thanks, Daniel. There are a number of ways that you can ask questions. You can type in your question in the questions panel on your control panel, as Mike showed you earlier, or just raise your hand by clicking the raise hand button. We have a question at the moment from Deborah. Deborah, I'm going to enable you to unmute. So if you click the microphone logo, then you will be. Could you please ask Daniel your question?
My question is, will AIMOS be compatible with IDE, an integrated development environment such as Eclipse or something else for test and development, so that developers will be able to integrate, because Eclipse integrates with Git and other things, and those things are important when you're in development going into production. I think that we have to remember that keeping version control and security, and instead of writing it ourselves, we can use what's already there.
Exactly, and it's a very good question. The short answer is yes, definitely. The way we provide AIMOS is as a library which integrates natively with the different ecosystems that you already have for your programming language of choice. So it integrates with Python, with C# as a NuGet package, Unity as an asset, and all of that integrates as an additional library which doesn't disrupt the workflow that a developer is accustomed to. That's very important for us.
Great, thank you. Have no other questions waiting at the moment, so if people could ask their questions, please do so either by raising their hands or typing into the questions panel. I was wondering, Daniel, obviously you have forecasts about how well you would like to see AIMOS do. What do you see the next 5 years looking like for this company? Is AIMOS going to become a name that we hear every day in the news, for instance?
Not necessarily a name you hear every day in the news. We see AIMOS not as something on its own, but as a tool. We see AIMOS, we'd like to hear of companies creating applications with AIMOS, and by doing so, fast tracking their development. That is our goal at Cyberselfs. And at this point, we are focusing on creating a whole workflow for creating these applications, including testing in VR, so that you can interact with the robot in virtual reality. You don't actually need to buy the robot in order to create an application for it. It's all about creating that family of products that can be linked together to provide the best value for developers and manufacturers and users by association, really, through developers and manufacturers using our product.
So you're not going to take over the world just yet. Mario, could you please ask your question?
Yes, thank you. Excellent talk. Thank you so much.
Thank you.
Very beautiful product. I want to ask you, maybe it's related to the first question, but like if I wrote a routine on MATLAB, for example, or any other language, and I convert it to an accessible library like ADLL file, so I can call it from AIMOS. So just I want to confirm that, so it can be called from AIMOS.
Can you repeat the question with regards to an ADL file? Did you say?
No. Just if I wrote a routine, let's say on MATLAB, I convert it to a DLL file, object library, and
Right.
can I call it from AIMOS? Like, can I call the functions from AIMOS?
So what you usually do there, the workflow for that would be you incorporate AIMOS for the specific language that you're going to be using. So let's say you compile the DLL in MATLAB and you now want to use that within a Python application. And so the Python application takes control of calling the AIMOS routines, and it takes control of calling your custom routine that you've created, and the Python application essentially then binds them together. So AIMOS acts as a sort of as a slave and needs to be driven by a master to get or set information for the robot.
Okay, so the interface with the robot or the motor actions, it will be from Python, not from AIMOS.
Exactly.
Okay. Thank you very much. Very clear. Excellent presentation, and thank you for the explanation.
Thank you.
Thank you, Mario. So I now have a question from A Steele. I'm going to enable you to unmute. So if you now click the microphone button, could you ask your question, please? A Steele. Yep. There you go.
Does one of the slides said you handle all the communication demands between yourselves and or the user and the robot? Does that mean the package, the SDK, does, or that the comms actually go via your own network, please?
No, so the SDK does. The way that it operates is that the SDK creates a connection with the robot, a peer-to-peer connection that doesn't go through another server. So the communication that you're sending, the data that you're sending and receiving to the robot goes directly to the robot. The only point at which the information is going through intermediary server is just to create the peer-to-peer connection at the very instance when you're connecting to the robot.
The initial handshaking.
I hope that answers. Yes, the initial handshaking. That's the only piece of data that goes through our servers. The rest of the data is purely peer-to-peer, and that is for security reasons, but also for latency reasons. It's much quicker to go straight to the robot.
Thank you.
Thank you.
Great. So, any other questions from any people? We still have a lot of people in the group, and definitely there are a lot of interesting ideas that Daniel brought up. Well, while we're waiting to see if anyone has anything else that's lurking at the bottom of their minds, have you got, do you have any anecdotes about strange things that you have used or been asked to use Telepresence for so far during the Cyberselfs existence?
So it's always very interesting to, when you put an idea out there, like Telepresence, just the capability of being able to remotely control a machine somewhere else, it's always very interesting to see sort of what comes back. What can I use it for this? Can I use it for this? Sort of one of my favorite applications is healthcare. So the fact that you could use robots within healthcare to essentially, there's a shortage of care providers at this moment. And most of that is because care providers have to go out, if they're doing house visits, they have to go out to each different house. There's a journey involved, there's time in the commute, and going to multiple houses sort of one after the other. Whereas if you had a robot that is your personal robot and you're using it in-house for things like doing the washing up, let's say, as an example, but doing some of the cleaning, if that were possible, making it financial incentive, an incentive for users to actually buy robots at home, then care providers could use that same hardware in order to go into the home and interact with people, combat loneliness, which is surprisingly a big issue with elderly people, but also, check in with regards to medication, or even handle emergency scenarios, where instead of they sometimes have this wearable key which you can press in the case of a fall. With a robot, you could have eyes on scene instantly while the ambulance is on its way, and you could deal with it quicker. So there's this element of helping others, but also the element of the quick response, which is very appealing when it comes to telepresence.
Yes, I can see that. Thank you. Mario has got another question. Mario, could you unmute yourself and ask a question?
Yes, thank you. Maybe it's not a question, but a comment, or what I want to say. I want to thank Daniel for this ambition and this goal to make AIMOS universal on many robots. And this is very challenging, and this is what makes this a product very important. So I don't know if he can add on the challenges that they faced, so they can operate on many robots, and what did they face, or the challenges they face, because this is really important, and this is what makes this product really amazing and very, very extremely important.
Thank you. Sure. So right off the bat, when you look at the different senses that a robot has, you've got the vision, the hearing, the talking. Most of it is quite straightforward, because in the end, it's almost like you've got a video call. You've got the video, you've got the two-way audio, but then in addition to that, you've got the physical presence on the other side. You've got feedback coming in. For example, you've got haptics involved as well. And so the biggest challenge there is, how do you completely abstract away the different shape of the robot from the control of the robot? And so that is the biggest challenge that we've faced / still facing in some ways. And that's the biggest thing that we're working on. If you've got a humanoid robot with 2 arms, that's very easy. You can create code which can control that robot. But then how do you also translate that code to, for example, an underwater ROV with a 3-axis or a 6-axis arm? How do you create a single representation for that motor control? And that is where the key challenge has been for us at Cyberselfs. Putting aside, of course, the challenge of the latency, getting that down, and the challenge of working with so many different platforms, when most of our competitors are usually just up to 2, whereas we have 10. But even just putting all of that aside, the motor control is the biggest issue, and that's where we've dedicated most of our work.
Interesting. So, I mean, personally, I can see, I spend a lot of time trying to work with people in entirely different field from where you're working, where they believe that we can abstract things to such a level that mere mortals can control computers or robots or whatever. And the trouble with abstraction is that you lose detail. And what you're basically saying is that you're trying to square that circle, provide access to whatever capabilities the robot offers, but at the same time not have lots of if then else statements in the code to cater for every possible robot that's ever created. You've set yourself quite a tricky challenge there, so it'll be interesting to see how that one develops over the years. We have a question from Carol. Carol, if you would click the microphone button and unmute yourself, would you care to ask the question yourself?
Hi, can you hear me?
Yes.
Yes, excellent. My question was, you've talked about sort of human forms of robots, perhaps to assist with companionship. So by extension, dog robots, cat robots. Is that something that you would maybe envisage?
Yes, we actually have a dog robot that's integrated currently. So I've got the Miro robot here on this slide at the on the very left of the slide. You've got that robot dog there. That is one of the platforms that has been integrated with AIMOS.
Right. Okay. In terms of sort of realism, I can see that it's a bit difficult to see on the side. I can see that the humans are very clearly aiming to be sort of very huge, have human characteristics. Does a dog sort of behave like a dog would and bark or something? How does it work?
So that's the thing. So the AIMOS application allows you to create code, which, for example, could make the Miro robot act like a dog. But because it's completely abstracted from the robot itself, you could take the same application that makes a Miro act like a dog and apply that to any of the other robots there. So you could have a humanoid robot acting like a dog because that's the programming that you've built in. If that makes sense.
Yeah, it's fascinating territory, isn't it? Thank you.
Very much so, very much so. And it's a great question as well.
So yeah, I've been present where at a public event where the Miro has been let loose on the floor of a Sheffield lecture hall, and watched it interact with the children that were there, and it was a very, yeah, it has mood feedback as well, so it tells you when it's happy and when it's angry, etc. So it is really interesting to be in. So
it's also surprising how you can take that mood feedback and also apply it to other robots as well, through the interplay of lights on the robot, through different audible sounds. Miro, of course, has the full package. It's got lights, it's got sounds, but with other robots, it's also possible to have similar behavior through a subset of either lights or sounds or both.
Excellent. And also, as you said right at the beginning of your talk, something that will cause consternation and concern in many areas of society. Okay, so I don't have any more questions at the moment. You have a last call if you have something that's niggling at your mind that you would like to ask Daniel. Otherwise, I will bring this meeting to a close. Daniel, thank you very much for a really insightful, interesting session. The recording of this session will be going onto the Edinburgh BCS Branch website, as will a PDF of the slides that Daniel has shown us. And although it sounds like the ANA Avatar X Prize semi-finals are not going to be live streamed, yeah, now that you've heard of them, why not Google them and track their social media output, and you can see whether Daniel and AIMOS make it through to the finals. Good luck, Daniel.
Thank you. And thank you so much to the British Computing Society as well. It's quite an honor.